Okay, I wanted to go over a couple of questions people asked about. This is number 47 from 5.1, and you've got sine theta over cosecant theta minus cotangent theta as you go to 1 plus cosine theta. Okay, when I look at this, I immediately see all these different trig functions on the left side and only cosine on the right side. And that makes me think we need to just change everything so that it's just sine and cosine on the left side, starting with sine theta on top. And I'm going to change the bottom. I'm just going to write the quotient identities for these. So cosecant is 1 over sine theta, and cotangent is cosine theta over sine theta. And now I've got this big complex fraction. I'm going to multiply the whole thing by sine theta over cosine theta, sine theta over sine theta, so that I can simplify it to just a simple fraction. So the numerator is sine squared theta, and in the denominator I have to distribute that sine theta to both of those fractions down there, and that's what's going to cancel those sine thetas down there. So sine theta times 1 over sine theta is 1, and sine theta times cosine theta over sine theta is just cosine theta. All right, and immediately I want to get everything to be a cosine now, so sine squared theta, according to the Pythagorean identity, is just 1 minus cosine squared theta. And I have over 1 minus cosine theta, and that should immediately make me think about the difference of squares. The numerator is the difference of squares, so I'm going to factor that into the conjugates. 1 minus cosine theta times 1 plus cosine theta. And then the denominator is going to cancel out with 1 minus cosine theta. And you got what you wanted, 1 plus cosine theta. So when you see those different, all those different functions on the left side, especially when they're all to the first power and they have like quotient and reciprocal functions, sometimes the best thing to do is just get everything to be sine and cosine. Okay, so this is number 33 from section 5.2, and you want to find the sine of arc sine 1/2 minus arc cosine squared root of 2 over 2. You want to find the sine of the quantity, the angle whose sine is 1/2, minus the angle whose cosine is squared root of 2 over 2. The first thing you have to remember is the range for arc sine and arc cosine, because you've got to make sure you're putting in the right values for these angles. So for arc sine, that range is negative pi over 2 to pi over 2. And so you have to make sure that whatever you write, whatever angle you write for arc sine 1/2 has to be in that range. And for arc cosine, that range is 0 to pi. So you've got to know those ranges or you're going to put in the wrong value when you find the arc sine or arc cosine. So we know from our unit circle that the angle whose sine is 1/2 in the range negative pi over 2 to pi over 2 is going to be pi over 6. And the angle whose cosine is square root of 2 over 2 in the range between 0 and pi is pi over 4. And I want to remind you, I'm allowing you to have your unit circle on the test, but you need to know it. You don't have time to fool around with that thing. You need to know those angles really well so that you're not searching the whole time to find these angles. You need to know them. So you're trying to find the sine of this difference. And if you subtract pi over 6 minus pi over 4, you're not going to get an angle that you know on your unit circle. So you need to use the difference formula for sine. And so that is going to be sine pi over 6 cosine pi over 4 minus cosine pi over 6 sine pi over 4. And so sine pi over 6 is going to be 1/2. And then cosine pi over 4 is square root of 2 over 2. And cosine pi over 6 is square root of 3 over 2. And sine pi over 4 is square root of 2 over 2. And so you've just got square root of 2 over 4 minus the square root of 6 over 4, and that is just square root of 2 minus square root of 6 all over 4. Okay, so on this one, you have cosine of the quantity inverse tangent of 8/15 minus inverse cosine of 3/5. All right, let's remember that these are just angles. Inverse tangent 8/15 is an angle. Inverse cosine 3/5 is an angle. So we're just taking the cosine of a difference. And so we're going to use that difference formula for cosine. We're going to draw these angles. So inverse tangent 8/15, that triangle is going to look like this. It's in the first quadrant. It has a tangent of 8 over 15, so opposite over adjacent. And if you use the Pythagorean theorem, the hypotenuse is 17. So I'm calling that angle A just so it'll have a name. And then for inverse cosine 3/5, that angle is in the first quadrant. It has a cosine of 3/5, so adjacent over hypotenuse. And if you use the Pythagorean theorem, you get the other angle, the other side, which is 4. I'm going to call that angle B. So basically, all I'm doing is I'm taking the cosine of A minus B. And remember, the formula for that is just cosine A, cosine B, plus sine A, sine B. And now all I have to do is fill in those values. So the cosine of A is adjacent over hypotenuse, so 15 over 17. And then cosine B is going to be adjacent over hypotenuse, 3/5. And then plus sine A is going to be opposite over hypotenuse, so 8 over 17. And sine B is going to be opposite over hypotenuse, 4/5. And so the 15 and the 5 cancel, and that's a 3, so 9/17. Plus, over here, nothing cancels, so 32 over 85. And if you get a common denominator and add all that up, it's just going to be 77 over 85.